Hi there, this is Vahid from the Art of Education channel, and today I'm going to show you how to do network programming things in Qt framework. Network programming refers to a way that programs can communicate with each other through a computer network. So the first point is that programs are not installed or run on the same computer. Although we can run them on the same computer, it's not necessary, and in reality they are run on different computers and they connected to each other over a LAN or a computer network. So we have two different roles in network programming, or two different applications: server and client. Most of the time we have one server and one or more clients try to connect to that server, and the server provides some services for the clients, and clients want to use those services and they request for those services from the server. To establish this type of communication, we need to define a protocol. A protocol is a standard pattern of exchanging information. As I said, a server provides a couple of services and clients want to use them. These services are somehow relating to creating and consuming data from the server to the clients. So protocols are like a set of rules or steps for communication. And there are two famous protocols used in network programming: TCP and UDP. This is a schema, or the big picture of communicating between two applications over a network. There are different type of layers here, and each one has its own responsibilities. TCP and UDP protocol are the one that we use in transport layer, and I recommend to study about these layers. This is not a very time consuming, but it's gonna give you a very good knowledge about how network programs works. So let's see what is the difference between TCP and UDP. TCP is the best choice when we need a reliable connection between the clients and the server. And it's a connection-based protocol. It means that we create a peer-to-peer channel between the client and the server, and each client has its own channel. And in addition to that, TCP ensures and guarantees the data order and also correctness. If any errors happen to data, TCP will recover the data or repair or fix the errors for us. So this is good when we need to receive the same data that's sent from the server or sent from the other point of the channel, other endpoints. And also TCP do a couple of handshaking to provide this kind of guarantee for us. And based on this fact, TCP is not a good choice when we need speed or efficiency in our communication, because we have some overhead in our communication. But on the other hand, we have some trustness. It's a trusted protocol that we can use for some sensitive data transmission. On the other hand, we have another protocol named UDP. In UDP, we send packets of data named datagram over the network for one computer, or we can broadcast it to all the computers existing in the network. And because of this nature, we cannot guarantee the data order or even the data correctness. And it's the best choice when we want to stream data over the network. For data streaming, we don't need to guarantee data arrival or even the data correctness, because data are not much important and they are not sensitive data. So if one packet lost, in general, it doesn't affect the whole system. Okay, and because we don't have such kind of handshaking that we had in TCP, here we have more speed and more efficiency, and it's the best choice, as I said, for streaming over the network. Another concept that I'm going to talk about is port. What is port? As you might already know, in one computer we can install or run a couple of applications that they want to communicate over the network. So they all have the same IP address. And when a packet received from the network, we need a way to identify this packet is for which application. The port is used for this purpose. The port is nothing but just an integer number from 0 to 65,535. And the first 1024 numbers are reserved for well-known applications such as HTTP, FTP, and the others. And by using a port, we can run a server, listen to a specific port, and then in the client we send data for a specific port on a specific IP address. So by combining port with the IP address, we can uniquely identify which application we are going to communicate with. So these are the basic concepts of network programming. And you can read more about these concepts online, and I recommend to do it because it's going to clarify your mind about what network programming really is. So what we will do in this session, I'm going to create two separate applications, a server and a client. And also I'm going to use another third-party application named Hercules that at the first section of this session going to act as a TCP server, because I'm going to start with creating the client application, and then when I create the server application, I use Hercules alongside with this client to connect to my server. And I try to do it in a widget application, so you can realize a real application instead of doing things in console application. I hope you enjoy it. Let's go to this is ILO, a helper software that take care of my eyes. I recommend to install it also on your computer if you're a Windows user. So let's go to Qt Creator and start creating from the client, and then go to the server application. So based on what we said earlier, we need to create two separate applications. First one is a client application and the other one is a server. Right now I start with the client application, and here I created a sample client application, an empty widget application in Qt. So, and for the server, right now I'm going to use Hercules in Windows, and you can use any other third-party softwares that mimic TCP server for you, and you can connect to them. And very soon I'm going to create a server application in this video. So the first step is to tell Qt I need to do some network programming stuff. For this purpose, you need to go to dot profile, and here alongside with core and GUI you need to add network also, and run qmake. Right now you are able to add network programming capabilities into your application and make use of them. The next step is to add a controller class. The main responsibility of this class is to manage the connectivity and also transmitting data to the device or server, and also receive the data from the server and parse it and generate appropriate data for our main window or for our GUI application. Although we can add this functionality to main window class, it's not recommended, and it's just good for some simple or some tutorial videos maybe, but it's not recommended, and we're going to add those functionalities in another class named device controller. So something wrong clicked. Okay, add new. I'm going to add a class named device controller, and also I'm going to inherit from QObject. Try to check these two checkboxes, include QObject, and also add QUdpSocket macro. And I'm going to change the file names to Pascal notation because it's more readable for me. Okay. So this is the class that we have, and we here inherit from QObject because we're going to use some signal and slots here. We're going to emit some events that happen through the QTcpSocket and inform our GUI that something happened. For example, we connect to the device, we disconnected from the device, some errors happen, or data received. And you can also update your state from my current data. First of all, we need to add prerequisite that needed for connecting to a server, a TCP server. Here I'm going to add QTcpSocket in this class, and also create a private field here named socket, QTcpSocket, and named underline socket. Okay. And also we need to add, for example, a method here, connect to device, and you need to pass IP address, or you can use QIP address, but right now we're going to use a string and also a port. Now let's press Alt and Enter and add the definition here. So this is the first step. I created a QTcpSocket in my controller device and create a connect to device, okay, with an IP address and port. we can save these two also here. Let's save them, string underline IP and int underline ports. Okay. And also we can grab these two parameters in the constructor, but right now I'm not going to do that because I'm going to change my connection to the other IP addresses during the application runtime. So I add a method named connectToDevice and pass those parameters in this method. Now let's go to main window form and add a couple of widgets on the form to grab input from the user. The input right now is the IP address and the port. Now I'm going to place a group box on the form and add two labels here. Where's the labels? Here, label for IP address, and this is one for port. IP address, and here is port. For IP address, I'm going to use a line edit with input mask also, and for the port, I'm going to use a spin box. For a spin box or for the port, I'm going to change the range from 1024 because we knew that ports from 0 to 1023 are reserved for system applications. So we start from 1024 and here we're going to 65,535, I think. Yeah, it's the maximum range. And for this one, I'm going to add a mask. The appropriate mask here is we need to enter. So it's ILO, an application that reminds you not to stare too long at your monitor and do some practice with your eyes. It's very good. I recommend to install it. So for mask, we need to enter 4 different numbers, 3-digit numbers. So I'm gonna use this mask. It's really helpful, I think. 000.000.000.000 and semicolon underscore. So what is? Let's do it one more time. 000.000.000. Something went wrong. Yeah, I think it's right now. Okay. Okay, now we have a place to enter 4 different only numbers in our line edit and change the names. Okay, it's going to be ln IP address, and for the other one it should be SPN port, and also I need a button to call the connect to device from the controller. Okay, it's connect, and let's change the name to btn connect. And anything else? Now let's apply a form layout here. Yeah, the layout is fine also. And I want to add some UI validation. If the entered IP address is not valid, I'm going to change the background to red, and also if the IP address is valid, change the background to green. And if you don't enter anything, it's something like this. It's going to be neutral, and no background will be applied to this widget. For this purpose, I'm going to use Stylesheet here in the main window. I added it before. Let's clear them and talk about them here. For the IP address, we can specify that widget with hashtag or number sign, and then the name ln IP address. This style sheet will be applied for to this widget specifically. Okay. Now, if I want to change the background, you can use background color to some red color, light red. Okay. And if I press OK and press apply here, you can see the background change. But I don't want to do background to change right now. If something entered and it's invalid, then I'm going to change the background. So here you can use properties. Here in the bracket, you can specify a name, a field name. I'm going to use a state as the name, and if it's equal to 0, it means that it's invalid. So you can apply the red color. And if I press apply, the background removed, because right now it doesn't have any property named state. And I'm going to copy this one and paste it one more time. And here I'm going to specify a state with 1. State 1 means that the IP entered is valid. So I'm going to add a background color with the color of green, for example. Apply. So if I add a property here, dynamic property, name the state, and I change it with 0, okay, the background changed to red. And if I change it to 1, the background changed to green. So it's okay. And also let's enable clear button. Clear button enable, okay. So you can right now clear anything entered with just clicking on this button. Now, let's remove the 1 from the state. And here, going to text change, I need to add some code here to text change a string. I'm going to check the entered string that passed as an argument to this method, and if the IP address is valid, then add the or update the property state values and repaint the widget again. Here I'm going to create an instance of QHostAddress named address based on the argument arg1, and then check if let's add the related header file also to this file, and I'm going to create, let's create property for a state, qstring state. By default it's equal to 0, it's not valid. Let's change it to 0. And if QUdpSocket dot IPv4 protocol equals to address.protocol. I'm going to check the address protocol. If it's a valid IP address, then the protocol automatically changes to IPv4 protocol. So if the address is valid, I'm going to change the state to 1. And then I'm going to update the line edit UI.ln. I need to build application. Qt Creator in Windows, somehow confusing to rapidly update the names and also stuff like that when you change them in the UI. Okay, UI.ln IP address dot property dot set property. I'm sorry, set property. I'm going to set a property named as a state, and the value is stored in the state variable. So if I just run the application, nothing will happen because we need to restyle or polish the widget one more time. Okay, here I'm going to call this style from the main window, style dot polish. Let's add also QStyle, number include QStyle, and style dot polish UI.ln IP address. Now let's run the application. Everything is okay. If I just press 1, it says, yeah, you entered something, but it's not a valid IP address. 192.168.1.1. So it's a valid IP address and it changed automatically. If I just clear the last one, again, it's not a valid IP address. If I clear everything that you enter, it also remains invalid. But for this purpose, I just need to remove the background color. Let's see how we can do this one. So here, I'm going to check if arg1 equal to 3 dots. By default, it's 3 dots, nothing entered in between. So I'm going to, so let's grab it here. And here I'm going to change the state to here to an empty string, and otherwise you go and create an IP a host address and check it's valid or not. So let's run the application one more time. For example, I'm going to connect to localhost, and if you press dot, it automatically moves to the next group. Okay, 0, 0, 1. So it's valid. And if I just clear the output, it says that, yeah, I'm empty and you're not input anything right now. So this is the UI part. Let's change this one also to information, connection, information. Now on press button, let's go to the clicked slot for between connect, and here I'm going. Now let's move this to also to the header file. Yeah. And also I'm going to include device controller header files. Now here in the private section, I'm going to add or to define a device controller, underline controller. I'm going to create a controller instance, a device controller instance in my main window. So here, let's remove these empty lines, and here I'm going to set underline controller. We're going to connect to a device by these IP addresses. Let's create those IP equal to UI.lineEdit ln IP address.text, and also for ports, auto port equal to UI.spn port.value. And here you're going to connect to this IP and ports. ILO shown one more time. Now let's go to this method. Here we don't have any code right now, but also we need to do a couple of things here. We need to inform the caller some state, our state, okay? The first state is connected state. So these are the state that declared in QTcpSocket. If I just open the help and it goes to, let's see, let's abstract socket. Okay, here we have some signals. The most important one is connected, disconnected, and state change. These are the default signals that we use a lot in our applications, and you can also use these ones when it's necessary. Okay, in our device controller, I'm going to create the same signals because when something happened to this socket, I'm going to inform the caller or the other classes that use this class as their controller to connect to a device. So I'm going to create. Let's go to TCPSocket and also go to abstract socket in the signal part. I'm going to copy these ones and paste them here. Okay, connected, disconnected, station, and also error occurred. I'm going to pass them with the with this class. Now I need to do another thing here. I'm going to declare them here. I'm going to connect, okay, ampersand or the address of underlying socket if signal QTcpSocket dot connected. If the signal emitted, try to connect it with my signal. Okay, I'm not going to add a slot and then emit my signal here. I'm just connect two signals to each other. It's possible in Qt. Okay, to this class and ampersand device controller dot or double dot connected. So if the signal connected from the socket emitted, I'm going to emit the connected signal in device controller automatically. And after that, I'm going to duplicate this one a couple of times and change the signal from connected to disconnected, state changed, and also to error occurred. Disconnected. This one is a state changed, state change, and also this one is error occurred. Now here, first of all, I'm going to check if these IP addresses and ports are the same as the previous one that I saved here in my instance. So nothing gonna change, and I just going to ignore the connect to device method calls. So I'm going to check this one. If IP equal to underline IP and port equal to underline port. It means that nothing happened, and these are when the device is open. Okay, I should check if underline socket is open. So check this one. If the IP equal to IP and port equal to underline or underscore port, just return, because the device is already connected to this IP and port. Okay, and otherwise, if device is open and the IP and ports are something different, first of all, try to close the device. Socket dot close, and then after that, here, if the device is open, we closed it, and here I'm going to connect to device one more time. But before that, I'm going to IP equal to IP and underline port equal to ports, and then underline controller underline socket, I'm sorry, dot connect to host, and then I'm going to pass IP address and port, IP underline IP and underline port. And if anything happened during the connecting to a host, these signals are gonna inform us, and we can do the appropriate actions in our UI. So let's see what I mean. I'm going to UI here, and I add a list widget here for some clarification reasons, and we're not going to use it. I'm going to change it LSD console to log something happened on the phone. So here again, I'm going to create a method, setup device controller, private method. Let's add it in the private section. Void setup controller. So I need to add a slot for those signals that I created in the device controller here to do some appropriate or some related action to each signals here in related slots. So let's grab those slots, those signals here, and create appropriate slot here for them. This part, let's say device underline connected, device underline disconnected, device underline state change, and device underline error occurred, and also implement them, add the implementation in the CPP file, and also name them error, and also here state. These two are very straight, and I'm going to, let's build the application, and I'm going to add something in LSD consoles dot add item connected to device. Okay, and also I'm going to copy this one and paste it here. Disconnected from device, and here I'm just going to convert these enums to string and show them on the list. So how we can do this? If we go to declaration for this attributes, you see that we just annotate them, or we just declare them using QUndelenum micro. So when you create an enum using this micro, you can convert it to a string using this approach. First, I'm going to create a QMetaEnum, and then I'm here going to call QMetaEnum. Let's add the appropriate header file. I'm going to call a method from type. Okay, and here you're going to it's a generic method, so you're here to specify the enum that you are going to convert their values to a string. So it's just this enum. Let's copy this one. It's the enum that I'm going to work with, and right now I'm going to again UI.lsdconsole.add item. Here I'm going to use metaEnum dot value to key, and pass the state that I received in the argument list. I'm going to pass it to this method, and this method called convert this enum to string, and I'm going to add it to the console. Let's do the same thing for the error occurred. Here I just going to change the socket state to socket error, and let's close the ILO. And here I'm going to pass the error. Okay, everything is just fine. And let's run the application. Okay, let's go to UI and try to expand the list. Now I'm going to run the Hercules, a third-party application that that acts as a TCP server for me right now. Now let's run the application without running the server. I'm going to say, okay, try to connect to localhost and on the port 12345 connect. If I press the connect, let's see what is going to. I think I forgot to add connect to device and connect to host. Okay, let's run the server. I'm going to start listening on this port and press connect one more time. It seems that something went wrong. Let's see if here socket is not open. IP connect to host, and I just connect these signals together. Let's debug the application. One, two, three, four, five. Press connect. Okay. Here IP equal port and socket connect to device. Okay. Nothing happened. It's weird. Let's see. Oh, I forgot to connect these. I forgot to connect these signals to these slots. Okay, let's grab them from here, from device controller. I'm going to grab these ones, and instead of socket, I'm going to use underline controller. And instead of QTcpSocket, I'm going to use device controller, and here I'm going to use main window as the class for the slots. Here I need to add the device underline in front of signal names. Okay, everything is just fine. Let's run it one more time. Now I'm going to close the server. Let's see what happened. And the port is 12345, and I'm going to prefix them on the next run. So you can see the states: hook lookup state, connecting state, unconnected state, connection refused, error. These are the states that we go through if there's no server listening for us. Now let's see, what if I run the server? So the server is already listened on port 12345, and if I press connect one more time, oops, something. Okay, let's see. Maybe we have some error. And I'm going to 12345. connect. So it says that connected to device. It's right now okay. And something went wrong. Let's see what is that. I'm going to stop the application and also stop the server. Here I'm going to run the application one more. Let's just change them. 127.0.0.0.1. So, and for the port, I'm going to use 1, 2, 3, 4, 5. So, on the first run, I'm going to connect to not running server. So, here this port is not open. IP port, connect to device, connect to host. And it says host lookup, connecting state unconnected, connection refused error. So I'm going to run the server and run it one more time. Here, socket is not open. Oh, socket. Okay. Although we cannot connect to the host, but it says that socket is open. So this is the thing that prevents us to connect it when we start the server. And let's see. We need to implement a slot for let's run the application. We need to create a slot, and when we see unconnected state or connection refused error, this one is much more acceptable. We need to close the socket, I think. Okay, let's see. Here I'm going to create another slot, private slots in our device controller, and I'm going to set socket underline state changed, and also name the parameter state and implement it here. So let's see what we have in socket state. There are a couple of states here. I'm going to use unconnected state. If state equal to QUdpSocket dot unconnected state, then underline socket dot close the socket, and then emit, the signal state changed with the state parameter to inform the other layers about what happened here. And here I'm not going to connect this one directly to the signal. Instead, I'm going to attach it to socket underline state change slot, and then I'm going to emit the state here. So let's run the application. I'm going to stop the server and connect to device at first. So unconnected states happened, and here I'm going to start the server and press the connect. So here I'm going to see the connect to device state. What if I just close the device? So here you can see disconnected from device, and here we can change the state. For example, if the device connected successfully, I'm going to change the button name to disconnect, and also change the color maybe to something, or I'm going to add a LED here to indicate that I'm already connected to the device. So here in the main window, when device is connected, I'm going to change UI.btn connect.setText to disconnect, and also I'm going to copy this one and paste it here. When we disconnected from device, when we disconnected, change it to connect. Okay, and again in BTN Connect, first we need to check the current state of the controller, and based on that we need to call the control connect to device or disconnect from device. So let's see. In connect to device, I'm going to create a method. Let's say that I'm going to create a method that returned the current state of the socket and named it state. Here I'm going to implement it. Something went wrong. Oh, it's in signals. Should declare it in public section. And I'm going to add a body for this method and just return underline socket socket.state. So I'm going to return the current state of the socket. And let's also add another method here, connect to device, void disconnect. Disconnect. Here I'm going to call underline socket dot close. Now in the main window here I'm going to check the current state of the controller. If and else underline controller dot state equal to QUdpSocket dot connected state, then just call underline controller dot disconnect. Okay, otherwise try to grab the IP and port and call the connect to device. It's one approach, but we can change it. We have a state here, but I'm going to add another method here, set boolean. The result is boolean, is connected. And here I'm going to check return underline socket dot state equal to QUdpSocket dot connected state. Now in the other layers or in the other classes, I'm just going to call this one. It's much more readable. If controller is connected, then try to disconnect it. Otherwise, try to connect to device. So let's run the application and see the results. I'm going to listen on this port one more time. Here, I'm going to connect. So we are in the connected state. And if I press disconnect, you can say closing state, unconnected state, disconnect from device. And one more time, I can connect to device. So this is the loop. And I'm going to connect to device one more time. Here, I'm going to close the server. So device unconnected, and here we have the connect button one more time because we changed it in the related slot in our application. So let's see what happened. I'm going to listen, connect to device. The labels is disconnect, but I'm going to close the server. And when the server closed, the button is also changed to connect. And if I press the connect, it's going to connect to device, but the server is already closed. And if I listen it, yeah, everything is okay. So we just created the appropriate loop for connecting and disconnecting from the device, and we control the sudden shutdowning of the server in our applications. So the next step is to pass some data to the server. So here, and also receive data from the server. First, I'm going to create the receive part. I'm going to send something here, and when send it to the server, I'm going to receive it and show it here. Let's see what we can do for this purpose. So let's first of all add a clear button for this list box or our console. I'm gonna add a button here. Let's grab them and put them in a vertical layout. And clear. Change it to clear. Also the name, also button clear. Now let's connect a signal from this one to the list widget and select the clear slot here. So if you press the button, it will automatically clear the list here, and we don't need to write any code for that purpose. After that, let's go to device controller. QTcpSocket provides another signal for us. Ready read. Ready read. Ready read is a signal that when data received from the server will emit automatically, and we can watch or we can connect a slot to that signal, and when data received from the server we got informed and we can work with the received data. And also you need to set a protocol between the client and the server, and based on the protocol you can parse or you can interpret the received data. First of all, I'm gonna create a slot here, socket underline ready read, and we don't need to add any extra parameter here. And in the constructor I'm going to connect ready read signal to underline socket underline ready read. Here I'm going to read data. We have an option here, for example, socket underline socket dot read all. Read all gonna return a QByte array that contains all the data read from the server. So let's save the data that we read from the socket, and I'm going to create another signal here named void data ready, and right now I'm going to pass the data to the signal. Okay, I just read the data and emit data ready. Here. So we're done in device controller. Now let's go to main window. The main window, I need to go to setup device controller and create another slot here, data ready. Let's also add appropriate slot here, data ready, and it provides QByte array. So I'm going to, let's see, ui.lst console.add item data qstring, convert the QByte array to data. Right now I'm going to pass some string data from the server. So I mentioned it before, and I'm going to emphasize it one more time. You need to define a protocol between the server and client. Most of the time we create a strike with some field in that, and when we receive data from the server, so we just copy those data to that strike. So and then we can just check the state or the thing that we received from the server, and we will do it in future very soon. Now let's run the application. Here I'm going to listen on port 1, 2, 3, 4, 5. That's okay. Oh, we need some error we have. Okay, data ready. Oh, I forgot to change here to device data ready. Okay, and everything is okay. Press the connect. We connected to device, clear the output, and I want to send it hello world. Send. You can see the text will be shown on the list box. Everything that you type here going to show on the console on our client application. For example, I am a message from server. Send it. You can see every time we pass the data will be received in the controller, device controller class, in the ready read slot, and then we just read the data from the socket using read all. We have another options here. You can read a couple of bytes based on your, for example, here you can read a couple of bytes here based on the thing or based on the logic in your application. But right now I'm going to use read all. and then emit the received data using a data ready signal, and we received it in our other layer or UI layer, and show it in the LSD console or list widget on the form. Now, I'm going to add the option to send data from the application to the server. Let's see how we can do this. Now let's add another group box here. Group box, send data. I'm gonna add a label. Let's grab it from here, and also text box here, and I'm gonna clear the mask, and also I'm going to add a button. Change it to send. The text, the name to BTN sound. This one is message, and Alan message. So I'm gonna apply form layout also to this one, and by default I'm gonna disable this widget. So in push in connect push button, go to slot, not this one, on connect, when device is connected, or we connect to device, let's see, yeah, this one, the device underline connected, I'm gonna enable this group box, and when disconnected or something happened that we disconnected from the server, I'm gonna disable the device one more time, the group box. Okay, let's change the name also, grp send data. Build it one more time, and here I'm going to use UI.grp, oops, it's not changing, UI.grp send data.set enabled true, and I'm going to copy this one, and on disconnect I'm going to say that grp not false. And let's see what we can do in the send button. Here I'm going to call a method underline controller.send UI.ln message.text.trim, and I'm going to create a method named send and pass the entered message in the line edit to this method. Okay, let's go to device controller, and here I'm going to add a method with the parameter, with the QString parameter. So here I'm going to call socket underline dot write. We have three different overload here. First one is a char array, a pointer to a char array. The second one is a QByte array, and the third one is a char array and the length of the data that we want to send to the server. So we want to write over a stream. So we open a stream and we write data over it, so the server can receive the data. Here we can just pass QString parameter message and call the QUdpSocket method over that. Okay, it converts it to a QByte array, and we can send it easily to the server. So let's run the application and check the server. Server is already open, and here I'm going to connect. So the group box enabled. Let's see, I'm gonna create a message from client. I sent it. Now we can see the message from client will be appear on the Hercules TCP server tab. Now you're able to send data in a two-way to your server. The server can also send data to you, so we can also send data again to the server. So this is the way that we can communicate with the server from the client. Now we're gonna create another part in our application. We're gonna implement TCP server application in Qt. Instead of using Hercules, I'm gonna create a server application. So we can communicate from our client to our server instead of using Hercules as the TCP server. Let's see how we can do this. First of all, I'm going to create a template for server for QWidget application in Qt, and then try to add code step by step, just like what we did in our client application. And also, let's see how we can make this one better a little bit. I'm gonna align them or add them to a vertical layout, and then add them in this way. So I think it's better. And also, let's add spacer here at the bottom part. Okay, I think now everything is okay. Let's run it one more time. Okay, this is our data and this is our layout, so we can move the data or move the form and resize it. Everything is now under control. Let's move on to the server application and try to implement it. Here I created another empty QUdpWidget application to act as our TCP server. First of all, we need to tell the compiler we're going to do some network programming stuff by adding network to our .profile and run qmake. Okay, everything just fine. Okay, yeah. Here I'm going to create a class to handle all TCP server things. I'm gonna name it my TCP server. Add new C++ class, my TCP server. Okay, it's gonna inherit from QObject and also include QObject and add QUdpObject micro. I change it to Pascal notation. So it's it. Here, private. I need to run a QTCP server. First, I need to add number include QTcpServer, and also each client that connect to the server will be managed through a QTcpSocket again. So I'm gonna add this class also, QTcp client, QTcpSocket. I'm sorry. Here I'm gonna create an instance of QTcpServer, QTcpServer, a pointer to this class, and I'm gonna instantiate it in the constructor. This is the server, and I'm gonna add a QList of QTcpSocket, a pointer to a QTcpSocket underline sockets list, because I'm going to add or to connect different clients to this server, so I need to keep track of all of them. So I created a list of QTcpSocket here. Now let's see how we can create a server. Here I'm going to create QTcpServer, instantiate it, QTcpServer, and pass this class as its parent. Okay. Whenever what is underline server? I forgot to underline. Whenever a client connects to a server in Qt, a signal named new connection will be emitted. So we can create a slot named a new connection received or a new connection and handle those clients that wants to connect to our server in that slot. So here I'm going to private slot void on client connecting, and there's no need to have any parameter. Here in the constructor I'm going to connect underline, because it's a pointer to the instance. We don't need to put ampersand before that, so it contains the address of the instance itself. Ampersand. Yeah, I'm going to QTcpServer of the new connection, and I'm gonna attach it or connect it to my TCP server on client connecting. So whenever a client connects to this server, this slot will be called. Now we need to tell the server on which port you're gonna listen, and also we set the address that this server should be looking for. So I'm gonna call server _server.listen. You should start listening to one port. The address I'm gonna use, the default one is QHost address that colon any. It says that every address can connect to me, so we used it. And for port, I'm going to use the 1, 2, 3, 4, 5. And also we can parameterize it. Let's parameterize it. I'm going to receive port from the constructor, and here I'm just going to use the port. And if you take a look at the listen output, it's a bool. So we should check. Maybe sometimes the port is not open or is not available, so we cannot listen on that port. So we should check if server couldn't be able to listen on that port. We should do another, or we should do something. And here on else. Now let's create a signal here. Void is server started. On the other hand, we cannot do that because we are in the constructor and we cannot connect this server here. Let's do it using if. If the server cannot listen on this port, we can just QDebug. Server could not start. Here we can QDebug. Server started. And let's see if the server started or not. I'm going to check it here. Bool underline is started. Okay. And here I'm going to assign it. Is started to the output of listen method. So right now, under if not underline is started. The same thing happened here, and I'm going to create a setter method, a getter method for this one. Create a getter method, and then we can check if the server started or not in other layer of the application. And here, right now, I'm gonna QDebug client connected to server. Now let's just see the output here. In the other programming languages such as C# or C++, we need to run this operation on another thread. By using a signal and slot mechanism in Qt, we can just handle it as a normal or an async operation. We don't need to run a new thread and try to listen for the connection on another thread, because it's a blocking operation and it can block or freeze our application. But right now, using this mechanism that we saw just here, we don't need to do these things on another thread. Here, when you when a new client request received to the server, you can get the socket for that client using this type. For example, this method auto socket equal to underline server dot next pending connection. Calling next pending connection in this slot will return an instance or pointer to the socket that we're going to use to interact with the clients. So I'm gonna use it very soon. Now, let's go to the main window, just as the client. Let's first a little bit narrow it. And here I am going to add a group box in the form. Server information. I'm going to grab the port from the user. So let's put a button here and also a label and a QSPin box. It says the port, the default, the default minimum is the 1024 and the maximum is 65,535, and the value will be 1024. Okay, it's right, and this is the start server. btn start server, and let's put them all in a form layout. Let's go to the slot for this button and also change the name. SPN server port. So here, first of all, let's add the header file for my TCP server here, and I'm gonna create an instance for this class in my main in my main window. And because I want to pass the port in the constructor, let's create a pointer to this class. Okay, my TCP server asterisk underline or underscore server. And here underline server equal to null ptr. In the start server, first of all, I check if the underscore server is equal to null ptr. I'm going to create an instance. Server equal to new my TCP server, and let's grab the ports from the UI equal to, let's comment this one and build the application. So the Qt gonna recognize the renaming things that I did before. Okay. Outer port equal to UI.spn server port.value, and passed it as a parameter to the server. This is the port. So otherwise, let's think about it in future. Okay. Right now, I'm just gonna check if the server is not ptr. Try to create a new instance of the TCP server. And I forgot to add. Let's go to QTcpServer. Here, I'm going to create a signal void new client connected. And after I got the reference to the new client, I'm going to emit that signal, new client connected. That's it. And in the main window, when I instantiate the server, I'm going to connect. Let's create a slot here again. Void on new client underline connected. And if the server emits new client connected, just attach it to the slot here. Main window dot new client on new client connected, and let's implement it. And just like the client, I'm going to add a list widget here to act as a console. List widget here, and also add a button to clear the output. Here the button clear. Okay, btn clear. Rename it to LST console, and let's connect the collect signal from the button to the clear slot from the list. and put them in a vertical layout. So that's it. And here I'm gonna let's rebuild it one more time. Now I'm going to add a text here, new client connected. This is just enough for now. Let's run the application. So I'm going, let's do one other thing here. After I created an instance of the TCP server, let's add something here. I'm gonna add a label here instead of LED. I don't have the LED right now. It's the LED. And I'm gonna change the size. Minimum size to 25 by 25 and also the maximum size to 25 by 25. And let's grab the Stylesheet things from the client sample. Where's the client? Maybe, yeah, it's okay. Change the style sheet. I'm going to grab this one and add it right here as the style sheet for the main window instead of let's press OK and add a name. LVL connection status. Add it and let's change the style sheet. Change the style sheet. Oops. Make a copy. Change the style sheet and add it here and also here. And by default, I'm gonna add a property here and change the color to red. State equal to 0. So server is not connected. And after I try to listen on the port, go to slots. I checked it here if out state equal to check if the server under the server that is connect is now. Let's see. Is started, okay? Is if server is started, the value will be 1, otherwise it will be 0. And then let's one more time go to the client and see here what we did for this part and add it here. LVL. Let's compile it. It's very annoying that Qt in Windows does not recognize the output, the change of the name in the UI until it builds successfully after that. So, okay, everything is okay. I'm gonna use LBL connection state, set a state as a property, and polish it one more time. Let's also add QStyle here. QStyle. And I want to run the application. Okay, I want to start or listen on port 1024. Yeah, allow access. It's okay. Now let's see what happens when a client tries to connect to this server. I run it one more time. Also, we have a warning here. That's because I created this slot on the basics of some predefined notation for slots in Qt. So I'm going to change it. New client connected. Okay, that's enough. New client. Let's change it to also camel notation. And I'm gonna change this one here and also here. So I'll run the application, the server application. I try to listen on ports 1, 2, 3, 4, 5, start the server, everything is okay, and server started also appeared on the console. And let's go to the client application. Here I run the client application, and let's run them side by side. Here I want to connect to the local host on this port, the port that is set here, and a server listen to that, connect. So as you can see, it says that new client connected. Now let's try to connect with Hercules again. Okay, let's clear this part, clear the window. I want to connect to the server on this port. Let's say connect. Okay, another client also connected here, and here we have the message that we want to put on the output or the console. So right now we just handle the connection, the connecting of a new client to our application. Okay, let's get back to my TCP server. Here we defined a sockets underline list. This list is used to save the sockets that just connected to this server. Here, when we grab or we receive the next pending connection, we just save this instance in the list that we declared before. Okay, and let's for a test, just I want to write a data here. Welcome to this server. When a client connects to this server, I just send back a message to them. Okay, let's stop the application and run it one more time. Okay, let's also change this one too. There's the value 1 2 3 4 5. Okay, I run the application, and here I said start listening. Okay, the server started, and here I want to, you know that you can see that we disconnected from the server because I stopped the server application. I connected one more time to the server, and you can see welcome to this server message sent back from the server, and I just print it or add it to this console. And if I connect one more time from the Hercules to my server, you can see again welcome to this server also passed to this client. Okay, let's disconnect the server one more time and connect it again. So we can see every time I connect to the server, a message will send back for the client. And here let's do what? I just save. Let's go back to the my TCP server. I just saved the instance of the socket in the socket list, and let's add a button to main window. I want to send a message to all clients connected to this server. So I added a button here. Change the name to send to all, and also change the name here, send btn send to all. And this is the message that I want to send to all clients connected to this server. Okay, message. And also let's add a group box here, this one, and server. Now let's say message information, and I just need to add a line edit, change the name to ln message, and layout this group box with form layout. So, and also let's add this one to a vertical layout. Okay, That's it. And also let's add a spacer here, vertical spacer. No, not this one. Here. Oops, yeah. Cool. Let's go to the clicked slot for btn send to all. Btn, the name is incorrect. Let's delete this one and change the name. Btn send to all. And one more time, create a slot for clicked of btn send to all. Here I want to call a method from my TCP server and pass a message to that method. That method goes through the socket list and send this message to each socket that's already connected to this server. So let's grab the message equal to UI.ln. Again, I need to compile the application. Okay, UI.ln message.text, and let's call the trimmed operation to delete all the blank from the start and the end of the message. And after that, I'm gonna call the server dot send to all this message. Okay. Now let's go and create this method in the server. Here I'm going to create another method, send to all QString message, and add definition to my TCP server. Here I'm gonna iterate through the list of sockets. Socket list, and for each socket I'm gonna call the write method and pass the message as 1 kilobyte array to UTF-8. So this is it. Now let's run the application, and also I'm going to, this is one client and starts the server. Hello world. And also I'm gonna clear this window. So I'm gonna connect to the server. Okay, welcome to the server. This is the first message. A new client connected appeared here, and also connect this one. Again, welcome to the server appeared in this console for me. And if I press the send to all, you can see hello world appear here, and also hello world appeared in the console window, or received data in the TCP client tab of the Hercules. So this is the way how you can communicate with the server. Now I want to add some other functionality to the server part. Till now we implement a one-way data transmission from server to client. So what if we want to send data from client to the server and show the data inside this console in the main window of the server application? It's very easy. When we grab the socket pointer or the socket instance in the my TCP server class, we can connect ready read signal for this socket to one slot here. So what does it mean? After I just received a new connection, I'm going to connect from this socket, and the ready read signals to one slot inside my TCP server. My TCP server client data ready. I'm gonna create this slot very soon. And also I want to connect the disconnect signal from the client, disconnect, to another slot here. Client this connected. Okay, let's create these two slots here. Private slot, void client disconnected, and the other one is client data ready. And also add the implementation for these two slots. in the CPP file. Here, let's also add two other signals here. Void client. Oops. Here it seems that we have extra client. Client disconnected, and I want to create slot client. Disconnect. This is one slot, and the other one void data received, and I want to pass a string as the data to the other layer, especially the UI layer. Here I'm going to emit client disconnect signal from the my TCP server application, my TCP server class, and here I'm going to read the data from the client or from the socket that sends the data. So I connected every socket in this application to this slot. How can I separate them? How can I separate which client sends which data? In every slot, we can call this the caller or the event source of the slot using the sender application. So I'm going to cast it socket equal to sender. I'm going to cast it to another things. That's QUbject underline cast, okay, to QTcpSocket, a pointer to this class. This line is said that, okay, please cast the sender to an instance or a pointer to an instance of a QTcpSocket. And after that, I'm gonna read the data from this socket. Okay, socket.read all. And again, I'm going to emit data received and pass the data and convert it to a QA string and pass it through this signal. So this is what I need to do in this method. Cast the sender to a QTcpSocket and then read the data over this instance, and then emit the appropriate signal from this class. And finally, in main window, I'm going to connect. Let's duplicate this line and connect data received and also client disconnect to two other slots. Let's create those slots. Void client disconnected and also void client data receive QA string message. Here I'm just going to add a log in ln messages and set that item dot add ln, no, not ln message, lst console dot add item client disconnected. Oops, something went wrong. So it's not important. Let's continue. And here again, I'm going to copy this line and what happened? Copy this line and append the message received to the console. So this is it. Let's run the application and see what happened. Client disconnected. Here I forgot to delete this client, and after that, oops, I think I forgot to modify this part. It's connect this one to client data received and this one to client disconnected. Now I'm going to build the application. Okay, everything is okay. Now I'm going to start the server. Let's run. No, the application is also is already run. Client application, connect this one. New client connected. If I disconnect from the server, you can see client disconnected message also appear on the console. I want to connect it one more time, and let's do this using TCP client. I connect to the server, disconnected, everything is okay. Connect it one more time. Sample data, I want to send it to both clients, and here I'm going to send data from the client to the server. From client to the server. Okay, send. As you can see, data from client sent to the server, and also here I can send another data, another data. Send it. So data also sent to the server. And in the next step, I want to retransmit data received from server to the other client. For example, if data sent from this client, I want to pass it to this one, and also if data sent from this client, I want to retransmit it to the client I just created in Qt. So let's see, what does it mean? Let's disconnect both of them, and here. Let's go to client data ready. After data received, I can just call the other method, send data, send to all. Okay, and pass the data read from the client to all clients. So there's one problem here. It also going to send data to the client that already sent it. Okay, let's see how it works. I run the server and start the server, connect to the server, and here I'm going to connect to the server again. So let's pass the data here. As you can see, the data received here, it passed it here, and also here the data also retransmit to the source client. To ignore or to prevent this transmission, we can copy this line and paste it here. Before sending data, let's change it to S, and also this one S, and I'm going to cast it to a string from this line. And here, that. And here, it's just enough to compare this S with the socket. If they are the same, we can ignore, or we can continue our loop, and it means that this is the socket that already sent data, and it's not necessary to send it back to this client. Okay, if S equal to socket, then continue. It's not necessary to pass data to this one, or we can implement it something like this. If S not equal to let's see what happened. If not equal to the current socket, then send data for that client. Now I try to run the application. Start the server, and let's bring those clients again. Clear this one, and also clear this one. Connect to the client, connect to the clients, and here I'm going to send data from this client. Okay, data sent here, and also data sent back to this, or sent again to this client. And when I want to transmit data from this client, if I press send, data here received, and we can also see the data that is received in the other client. So somehow it's like a chat room application. And you can do a lot of funny things or a lot of useful or applicable things in your application using these techniques, and you already know how to create TCP server, TCP client, how to connect or manage connection between them, and how to transfer data between clients and servers, and also to retransmit or resend data that received in the server to the other clients. I hope you enjoyed this session. It's get a little bit long, but I think it's necessary to understand different aspects of network programming in Qt. This is just the beginning, and I recommend to read the manual or the help in the Qt documentation. It contains a lot of useful information about the network programming. I will record another video about the advanced topics in network programming in Qt in future. Till the next session and another aspect of Qt programming, goodbye.